everyone, my name's Logan. Welcome back to the lecture hall. Today we're covering section 4.2, the mean value theorem. And we're going to start with a theorem. But not the mean value theorem, ironically. We're starting with Rolle's theorem. And it states, let f be a function that satisfies the following three properties. 1. F is continuous on the closed interval ab. 2. F is differentiable on the open interval ab. And 3. F of a equals f of b. Well, then, there exists, okay, and we see this, oh god, what is this? Like backwards E thing. This means there exists. And the reason why I use this notation is because I assume, if you guys are watching these videos, you're either interested in math or have to take math. And these symbols are very common in later forms of math, so I'd rather start doing them now rather than just throw them at you when you start, I don't know, a proofs class or whatever it may be. So then there exists a C in AB, C is just a constant, such that f prime of C equals 0. And what does f prime of C equals 0? That's a critical value. So that means either a local max, a local min, an absolute max, an absolute min. And now I just drew a picture, too, actually, to kind of prove Rolle's theorem. I'm not going to go through with the proof of Rolle's theorem. You learn it in 140b, I think, 140a or 140b. But basically, it shows, you can see if a is equal to b, then if you were on this curve, it hits some point, a max or a min, and then if you hit a max or a min, you get that the slope, the derivative of the function, is equal to 0. Now onto the actual mean value theorem. Let f be a function that satisfies the following hypotheses. Whatever. F is continuous on the closed interval ab, and 2, f is differentiable on the open interval a to b. Okay, then there exists, backwards E, there exists a C, just a constant or number in AB such that f prime of C is equal to f of b minus f of a all over b minus a, or you could write it in the form f of b minus f of a is equal to f prime of C times a minus b. And you see this formula, and you're probably like, hey, I know that formula. We know that m of our slope is equal to y1 minus y2 over x1 minus x2. So what this is saying is that the line made between f of a, or between a and b, with f of a and f of b being your outputs, there will be a slope that is equal to it. One of your derivative outputs will be equal to the slope made by this line, right, between a and b. You get the same slope somewhere. And if we were to look on our function, we just kind of see, okay, so it's tilted like that, and we just drop it down to there, and we see, oh, well, here's a flat part of the curve, and it looks like it goes like that. And we see, hey, this works, right? And this is another very important theorem. You'll be learning it in the 140 series, why it works, why it's important. Actually, 140, which is Introduction to Analysis, is real analysis, is an awesome course. I find it to be kind of hard, but very interesting. But this is the mean value theorem. Another theorem we have states that if f prime of x equals 0 for all x in a, then the function f is constant on a and b, or from a to b, the open interval a to b. And what is this saying? Well, it's saying if its slope is 0, right, the change in the function, like its slope, it's going to be flat for all from a to b, right? It's going to be some sort of thing, because a straight line that is parallel to the x-axis has a slope of 0. So what it is saying is, if its slope is 0 from a to b the whole time, it's going to be a constant function, and it's going to be flat. A corollary to this states that if f prime of x is equal to g prime of x for all x in a to b, then f minus g is constant on ab. And what is that saying? It's saying that f of x is equal to g of x plus some constant c. Well, what is that? What does that mean? I don't know. Well, it's saying, well, look, if the derivatives are equal to each other, then the functions are going to be equal to each other, and or nearly equal to each other. They're going to be shifted by some position, right? Because when you were to do the derivative, if you take the derivative of a constant, the c would go away, right? So if you had your f of x is g of x plus 5, let's say, and you differentiated both sides, you would have f prime of x is equal to g prime of x plus 0, right? So then they're just equal to each other. And then what this little subtraction part is saying is that when you subtract the two, all that we'll have left is this c, and it will be just another flat line at whatever it may be. So this is all for the lecture portion of the video. Let's transition into the practice problems. Now onto the practice problems. We're going to be doing number 5 and 12. And they're both very similar, except they're, using the different theorems. So this says, verify the function follows Rolle's theorem, then find all the numbers that it works for. Then find all the critical values, you may say. So what are the three hypotheses that you need to follow? F is continuous on the closed interval. Well, it's a polynomial, and all polynomials are continuous on closed intervals, so we know this is a check. F is differentiable on the open interval. Well, polynomials are all differentiable at any point. They're a smooth function, so they have derivatives of all orders. And then finally, does f of a equal f of b? So f of negative 1 equals f of 3. Let's see. So f of negative 1 is equal to 2 times negative 1 squared minus 4 times negative 1 plus 5, and that is equal to 2 minus plus, because that's 4 now, not negative, plus 5 is equal to 11, correct? Yes. And then so we have f of 3 is equal to 3 squared minus 4 times 3 plus 5, and that is 9 times 2 minus 12 plus 5, and that is equal to 18 minus 12 plus 5, which is equal to 11. So it works. So we verified that it works for all three things, and now we just need to, the outcome of Rolle's theorem states that then there exists a number c in a to b such that f prime of c equals 0. So we just need to find our critical value. All right, let's do it. So we have the function. How do we find critical values? Well, we differentiate, and this is power rule. So f prime of x is equal to 4x, power rule, minus 4 plus 0. Okay? So then we want this to equal 0, so that's 4x minus 4. Okay? And then we get 4 is equal to 4x. This is because we added 4 on both sides. And then we just divide by 4, and we get x is equal to 1. And then we check. Is that in between negative 1 and 3? Yes, it is. So this is our only value. And we see, okay, Rolle's theorem, it does work. Next problem, number 12. Verify the function satisfies the mean value theorem and find the values it works for. Well, we have our mean value theorem, and it states, let f be a function that satisfies the following hypotheses. 1. F is continuous on the closed interval a to b. Okay? And then 2. F is differentiable on the open interval a to b. Okay, well, yet again, these are polynomials, so we know that they are going to be continuous and differentiable on all points of the real numbers. Okay? And so then it states, then there exists a number c in a to b such that f prime of c is equal to f of b minus f of a divided by b minus a. Okay, so now we can just solve it. And when I mean solve it is I need f of 2, f of negative 2, and then negative 2, or 2 minus negative 2, and we find where this works. So we're going to have to take the derivative of this first. So we get 3x squared minus 3x, or minus 3 plus 0 is equal to, well, what's f of b? F of b is going to be f of 2, which is f of 2 minus f of negative 2 divided by 2 minus a negative 2. Okay, what is that equal to? This is equal to 2 cubed minus 6 plus 2 minus negative 2 cubed plus 6 minus 2, correct? And then we have to distribute our negative, right? So there will be a negative here. This will become negative, and then that will become negative, right? And then we get all over 4. What is this is equal to? This is equal to 8 minus 6 plus 2 minus a negative 8, so plus 8, right? Because the negative stays, minus 6 minus 2. Okay, and so that all looks correct. That cancels with that, and then we get 8 minus 6 over 4. Well, 8 minus 6 is 2. 8 minus 6 is 2. We get it's equal to 4 over 4, which is equal to 1. Okay, and then it says 3x squared minus 3 has to equal 1 at some point. Okay, well then we just subtract by 1, and we get 3x squared minus 4 is equal to 0. Alright, then we found, 3x squared minus 4 equals 0. This will satisfy, if we find the x's, this will satisfy our mean value theorem for this equation on this interval negative 2, 2. Okay, how would we do this? Well, I'd start by dividing by 3 on both sides, and we just get x squared minus 4 thirds is equal to 0. Okay, and it's like, oh god, this looks really bad. But we have a property that states x squared minus a squared is equal to x minus a times x plus a. Okay, so look, we have an x squared minus, well, I guess that could be, that's a squared because it's a real number, so it can be square rooted. And we see, okay, well then we just break it up. Then we get x minus a, or x minus the square root of 4 thirds times x plus square root 4 thirds. And then what is this equal to? That is 2 over root 3. And then that is x plus 2 over root 3. And then if you do your calculations, you will find that that if you set x equal to positive or negative 2 over root 3, it will work for the mean value theorem, and 2 over root 3 is going to be in between negative 2 and 2. So this is how we would do problems like this for using Rolle's theorem and the mean value theorem. Again, my name was Logan. Thanks for watching. Have a great day.